Hello and welcome to a new part of this tutorial series. Today we're going to take apart merge sort. So if you want to know how merge sort works, stay tuned. I'm going to explain it in the first couple of minutes. And then in the next part of the tutorial, I'm going to implement it in Python, and then we're also going to visualize it with our tool. Since we have a lot to do today, let's stop talking and start coding. Let's start by explaining the algorithm. So merge sort is divided into two parts, splitting the list and then merging it back together, which might sound stupid, but it works. Let's start by splitting the list. We always split the list in half. And we then divide it in the left half and the right half recursively, which means that we just want to split the list in the middle, and each list then in the middle and in the middle and in the middle back again. So let's just do that. So 3, 15 and 8 is going to be one list. So let's put it on the left right here. So 3, 15 and 8 is going to be one list together. And then 39, 12 and 7 is going to be one list together. And then merge sort calls itself again recursively. So let's split these two lists again, as long as we can split them. So this is going to be 3 and then 15 and 8. And on the right side, we are going to split it again into 39 and then 12 and 7. And since we still have lists available that have two elements or more, we still want to split it. So let's split 15 and 8 into two separate lists as well. And then on the right side, we want to split 12 and 7 into two separate lists as well. Awesome. Now we have basically in the end nodes, we have 1, 2, 3, 4, 5, 6 lists for 6 elements. Awesome. This is the first part of the algorithm. We want to just divide it into basically nodes. Now we have created 6 lists with one element each, and that is going to be the first part of merge sort. Since we split it up going from top to bottom, now we want to put it back together from bottom to top, and we're going to merge these lists in the sorted order back together. Which now means that the first step is going to be on the left side, and we're just going to merge 15 and 8, and let's just now merge it together. So 15 and 8. 8 is less than 15, so let's now merge it together to a list of 8 and 15. So that means that on the left side we now have one list that contains the number 3 and one list that contains the numbers 8 and 15. Let's now merge the left side again. So 3 is going to be the smallest element, 8 is going to be the next smallest element, and 15 is going to be the, again, next smallest element in the list. Awesome. But now we don't have a right side to merge it with, so we have to hop over to the nodes on the right side. And again, we want to merge 12 and 7 together, so 7 is less than 12, and then we have the 12. Let's now merge together these two lists, the 39, which is the first list, and then 7 and 12, which is going to be the second list. And we just want to merge it together as a sorted list, so 7 and 39, let's compare them, and 7 is less than 39. And then we want to compare 12 and 39, and then 12 wins again, and then the 39 is going to be the last element because we do not have anything else left. And now we have two lists again, so on the left side 3, 8, 15 and 7, 12, 39, which are two sorted lists. And let's now merge them together. And this is going to be simple, just 3 compared to 7, and then we have these 3 away. And then we want to compare 8 and 7 is less than 8, so let's put it in here and let's put the 7 away. Then we want to compare 8 and 12, and 8 is less than 12, so let's put up an 8, and then put the 8 away. And then we want to compare 12 and 15, and 12 is less than 15, so let's put the 12 up here and put this 12 away. And let's now compare 15 and 39, and 15 is less than 39. And then we want to put up the 15 in here, and 39 has nothing to be compared with, so they just pop the 39 in here. And this is basically how it works, as I showed you on the last lists, because I do want to leave these steps down here at the bottom so that you can figure out how we created those lists before. But we are basically just going to pick the elements that we want and put them in the final list and sort them that way. Let's go over merge sort again. So we want to split up these lists into sublists and then change them up on the way back, just the same way as we split them up. And this is basically all that we have with merge sort. It's very fast on really large data sets, and it always has the same exact speed, which is very fascinating for an algorithm. It's always n of log n. One downside of merge sort is its spatial requirements, which are very, very high compared to, for example, bubble sort, which just runs through the array that we have. If you are still unclear with merge sort, just leave a comment down below. I'll try to explain it to you, or just rewatch this part. And let's start with the coding part. Let's start by creating a new file, and let's save it as mergesort.py. And we want to import the time because we know that we're going to use it, just as we did in the last tutorials. And then we want to define a function. Let's call this merge sort. It is going to take in the data array and then a draw data function, just as always. So draw data and then a time tick. like that. Awesome. And once we get the data array, then we want to call a new function, which is going to be basically our merge sort brain. So let's call this the merge sort algorithm, which is going to take in the data array, the left index, the right index, the draw data function, and the time tick. And the merge sort function is just going to call the merge sort algorithm. So merge sort algorithm, we want to pass in the data, and for the left index at the start, it is going to be 0. The right index is going to be the length of data, and -1, do not forget that. And the draw data function is just going to be draw data, and time tick is just going to be the time tick. Awesome. And once we call that, we want to perform the merge sort algorithm function, which, as we did before, we want to first off get the middle index so that we can split the array. So middle is going to be equal to left plus right, and then divided by 2. And we want an integer value. That's why we have to put in 2 division signs right here. And then we want to call the merge sort algorithm function. So this one, that is the recursion. And we want to pass in the data, then the left and the middle, and then the draw data function, and then the time tick. This is just going to be basically something that we pass on all the time. Let's copy this function one more time. And this time we want to split it in the middle plus 1 so that we do not include the middle again. And we want to split it from the middle plus 1 to the right index, and then the draw data function time tick is going to be the same. And then we want to call some kind of merge function, which is just going to somehow merge 2 lists together. And we want to merge it with on the data array. And we want to merge it from the left index to the middle, and then from the middle to the right index. And we want to visualize it, so just pass in draw data and time tick like that. And we do not have a merge function yet, so let's define a merge function. And again, this is going to take in the data, left and middle, and then right, draw data, and time tick. But one very important thing with recursion is we have to have some kind of condition where we want to stop. This condition is just going to be if left is less than right, then we want to continue, because the left index has to be at least 1 smaller than the right index. So that is the 2 driver functions complete, and let's now work on the brain of the function. So once we get in here, we want to split it into the left partition and the right partition so that we can actually complete 2 lists. Right here, we created 2 lists and we split them in the middle, and then we want to complete those 2 sorted lists. And we just simply do that by getting a left partition. So left part is going to be equal to the data from the left index to the middle index. And we have to add +1 right here because it does not include the last index. And then the right part is going to be from the middle point +1 because we included the middle in the left part already. And then we want to put it from the middle to the right +1 again, because it does not include the last part. Then we have to get 2 indices, so the left index for the left list and then the right index for the right list. Both of them are going to be equal to 0. Okay, let's now loop for it. And we want a for loop, and this is going to be the data index because this is going to point to our main array. And we want to loop for the data index in range, and we want to start from the left and then end at the right. So right +1 again because we do not include the last index. And this is going to be a little bit more complicated. So first off, we have to check if both indices are in bounds. So if the left index is less than the length of the left part, and we also want the right index to be less than the length of the right part, because they do not have to have the same length. And then we just want to check if the left part on the left index is less or equal to the right part on the right index. Then we want to put the right part on the data index. So data on the data index is going to be equal to the left part on the left index. And then we just want to add 1 to the left index. So left index plus equals 1. That is just the same thing as we did in the explanation at the top level. We basically just threw away one of the parts, which is just the same thing as putting the pointer 1 to the right. And right here I have an error. I have to have an equal sign right here. So left index equals right index, and it is equal to 0. And then if this is not true, so else, then we know that we're going to use the right index. So the data on the data index, on the current index to the data, is going to be equal to the right part with the right index. And then we have to increase the right index plus equals 1. Awesome. Now we have to check one more thing. So right here, the left index might run out of the left part array right here, but the right index might still be inside the right part. So we have to check which of those 2 we ran out of, because those 2 sublists do not have to be perfectly sorted so that they just put in one after the other, after the other, after the other, and so on. So now we want to check if the left index is still inside the left part, and if that is true, then the data on the data index is just going to be equal to the left part, so left part on the left index. And then we have to increase the left index, and else then we do not have to check anymore, because if this is not true, then we know that this is going to be true. And then we want the data on the data index to be equal to the right part on the right index. We also have to increase the right index plus equals 1. Awesome. So this is basically going to be all the code for the brain of this function. And now we also have to obviously test it, and we can just simply test it out by creating a random data array. So let's do something like 1 blah blah blah, just create a random array. It should work on any array like that, for example. And then we want to call the merge sort function and pass in the data array. And it does want more parameters, so just put in 0 and 0 for the time tick and draw data. It does not matter right now. Open up the terminal or just start it any other way. And we want to start the merge.py with Python 3. And I get an error because I used the wrong variable, and I want the left part on the left index right here. And if I restart it, I should be fine and get a sorted list out of our input list right here. Awesome, now that we know that it works, we want to implement the visualization as well. So let's remove these 3 driver lines, we don't need them anymore. And let's now make a new function, and let's call this the getColorArray. This function is going to get a length, so length, and then we want to get the left index, the middle index, and then the right index. Let's create an empty color array, and this is just going to be equal to an empty array, and then at the end return the color array. And we want to cycle for I in a range of length. First off, we want to check if we're working with the current sublist. So if I is greater or equal to left and I is less or equal to right, this is going to be one condition. And then we also want to check if I is greater or equal to left again, and then I is less or equal to the middle point. So this one is going to be equal. Then we want the color array dot append, and we want to append the color yellow. And else we just want to append the color, and let's say something like pink. And if we are not working in the current list, so the else right here, then we just want the color array dot append, and we want to append the white color, so that we know that we are not working with the current array. Awesome, that is our getColorArray function. So let's copy the name right now and figure out where we want to actually visualize it. The first area where I would like to visualize it is at the top of the merge function. So let's just call the drawData function, pass in the data array, and then the color array, which takes the length, so just length of data. Then we want to pass in the left, in the middle, and then the right. Awesome. And then we want the time.sleep function, and we want to sleep for the time tick amount. Let's copy these 2 lines, and right here when we finish sorting the array, let's also have the array colored green. And we just want to do that if we are inside this current sublist. So we want color green if x is greater or equal to left, and x is less or equal to the right, and else you want the color white in here, and we want for x in a range of length of data, like that. Awesome. So once you have this, we can also implement the merge sort algorithm inside the sorting algorithms.py. So to do that, just hop over here and import this function. So we want to import from merge sort, and we want to import the merge sort function, not the algorithm, just the merge sort. And then scroll down to your combo box, and right here we have the merge sort. So select it, and let's copy the merge sort string. And then we want to check right here where we have the start algorithm. We want to check if the algorithm menu.get is going to be equal to the merge sort string. And if that is true, we want to call the merge sort algorithm. We want to pass in the data, the drawData function, and then the speed scale dot get value, so that we get the time tick value. Awesome. And right here where we have the drawData function that we want to call after we finish quicksort, let's cut that out by Ctrl X and then just paste it down here after all these functions, because for every single function that we have, we just want to color it green once we finish it. And now if I just start the app, select merge sort and just generate some kind of array, hit the start button, and if I hit the start button, I see that the first thing that gets done is the sublist creation, which we don't want to really color, it's kind of unnecessary. And then we see that every single time we select a element, right here we have 2 elements in a list, so the left and the right part, and then we sort them and then we color it green. And right here we're going to select the left part right here, the yellow, then the pink part was the 15, and then we sort the sublist. And again, we merge these 2 lists together. That's the merge function, and we get a sorted list. Awesome. Make sure to play around with it, color different things, go through the algorithm if you're not quite sure what it is. I hope you enjoyed this tutorial, and I'll see you in the next one with a new sorting algorithm. So stay tuned and bye!